I'm Aliaksandr Zhukovich, an Android developer, and today we will talk about efficient ways of testing Android applications. We will talk mostly about UI testing. However, at the end of this talk, we will have a lot of different tips for testing in general. First of all, I have a few questions. How many of you write Android tests? And automation tests? And how many of you verify UI? Oh, just few percent. Okay. So let's start from the very beginning. In addition, in general categories of tests like unit integration and acceptance, we have two special categories only for Android tests. It's local and instrumentation. When we speak about local tests, it's tests which we can run on our laptop, maybe PC workstation, and instrumentation tests require device or emulator. Local tests can be run on our device, and we cannot, by default, test any Android-specific components like activities, services, and stuff like this. However, we can use RoboElectric framework, which give us these possibilities. In instrumentation test, we have separation for UI and non-UI components. When we speak about UI components, we can use verify our user interface. With non-UI, we can verify services, files, broadcast receivers, and stuff like this. As I said at the beginning, mostly we will speak about UI tests. And when we speak about UI tests, we should interact with some views on the screen. For getting additional information about this view, we have two tools. It's Layout Inspector and UI Automator Viewer. Main difference between these tools is that UI Automator gives you information about all views, about all applications in the system. It can be any application from any developer. However, Layout Inspector can analyze only your application. When I speak your application, I mean application which you are developed. At the beginning, let's start with the process of running tests and what is going on when we press Run button in Android Studio or run Gradle task. First of all, we should generate two application files for our debug or production application and for our test application. Later on, we use adb command for install this application on device. A test application interact with instrumentation API, and in this way can interact with our debug application. In this way, our test application can interact with a real application. Today, I will be mostly speak about this application. This is pretty simple application, which store nodes connected to the coordinates. And main idea here is that first of all, you should log in or create account, and later on you can add nodes and search and add to the map nodes connected with coordinates from any user who uses this application. Let's take a look at one of the simplest scenario from this application. And here we can verify login screen. Here we just looking for. Can you see something on the screen? Okay, first of all, we are looking for a view with ID email and enter some email. After it, we press to sign in button, and finally we verify that we can see this error. As you can see, here we use Espresso framework, which is pretty simple, even for people who don't use this framework at all. But for people who know Android Studio very well, have a question. Should we even spend some time for learning even basic of Espresso framework if we can use Espresso Test Recorder? Espresso Test Recorder is a build tool in Android Studio which help us to generate Espresso test. You can run it from Run menu and run Espresso test. And here, we can just press to different views, and we can see that code which will be generated. Even if we avoid delays, because Espresso helps us to avoid these delays, however, this tool has some problem with them. I tried it on different operating systems on Linux, Mac, Windows, and with devices and emulators, and more or less always I have the same problem. And the main problem is code which will be generated. Espresso test recorder generate code like this. And as you can see, it's a problem, because this test is unmaintainable. We can write the same test with just three commands, 3 lines, and Espresso test recorder try to verify everything what is possible. And of course, it's horrible idea to add a test like this just for production code or just to your test code. Let's take a look at more complicated scenario when we move in between different screens. And here we start from our splash screen. Later on, we move into sign-in screen. We do some sign-in. We can see the map and do sign out. It's pretty simple scenario, but as you can see here, we have a lot of code. And default synchronization in Espresso is 16 milliseconds. And of course, 16 milliseconds is not enough when we speak about communication with server, interaction with huge database, and do stuff like this. And Espresso supports idling resource mechanism. In this case, we use map visibility custom idling resource. And this idling resource can wait some time for you. And after it, next step will be executed. And as you can see, you should spend some time for reading this test, and you should control flow. You should know which view you have on different screens, and do stuff like this. And of course, it's pretty complicated, even for people who pretty long work in the project, because project will be bigger. You will have much more complicated layouts. You will have much more screens. And fortunately, we can solve this problem. And our solution can be domain-specific language or simple DSL. DSL is kind of language for our domain. Let's imagine that we have some navigation application, and our DSL we have words like search, clean route, plan route, and stuff like this. Let's try to rewrite these 3 simple lines with our DSL. Here we enter some email, password, and press sign in. If we would like to do it more clear for the user, for the developers, new joiners, and people who are working on the project, first step, we will use a robot pattern. Main idea robot pattern that we can create different robots which will verify all our code. In this case, I created different robots for each screen. First of all, we can move all basic operations like enter text, click to the view, to some base classes, because many robots will use these basic operations. Later on, we can create robot for sign-in screen, and with sign-in functions. When we just enter email, password, and press to the sign-in button. And finally, if we would like to use this code in Kotlin, we can create functions which will have a lambda with any functions from a sign-in screen robot class. And finally, we can have code like this. As you can see, this code much simpler, and even any new joiner can understand this code, because this code is pretty clear. And we can rewrite all this long scenario to code like this, which is pretty simple and understandable, I think, for everyone. Of course, we can create internal DSL and spend some time. We can improve it during application development, and internal DSL solutions can have provide some benefits and create some problem for us. Let's start with benefit. First of all, it's readability, because any code with DSL much simpler. If we come back to the previous scenarios, and let's imagine that we have a lot of different tests, like 10, 20, or something like this, probably you will have a big amount of steps, and you can run new tests very fast without generating any additional step. In one moment, you can change some ID or maybe some error message for your application, and you should change it just in one place, and all your tests will be fixed without any problem. But we have few problems. First of all, it's building complexity. Because it's from the very beginning, it's pretty complicated to create really great DSL. Main idea is that maybe at the beginning of your application, when you have just few functionalities and few screens, you would like to avoid sign-in operation, which will enter email, password, and do sign-in. Maybe you prefer enter email, enter password, and press sign-in. Maybe it will be better for you. However, while your application will be bigger, probably you would like to enter additional abstraction which group some of actions. And of course, it's flexibility. And in flexibility, everything depends on your abstraction. If your abstraction will be really high, some cases will be really complicated to test. Move to the next big topic is testing interaction with the server. However, many tips from this part can be used not only for interaction with server. We can use these tips also for interaction with any dependencies, like database, files, shared preferences, and stuff like this. We can verify we can interact with our server in few different ways. First of all, it's end-to-end test when we can interact with our debug or release server. Next option is mock interaction with server, when we can mock some responses from the server. And here we can use REST mock, wire mock, and other tools like this. And we can mock one of our layers. This approach requires some testable architecture, because if you have testable architecture, you can mock one of your layers without any problem. Let's take a look at these three scenarios. First of all, when we enter some correct data, send them to the server, and get some response from the server. Pretty similar situation with incorrect test data. And last situation when we can handle some of our incorrect data on the client side. Of course, we cannot verify all data on the client side, but let's imagine that our email is a simple string which is not email. And in this case, we can verify without any problem. However, I would like to speak only about first scenario, because it will be more interesting for us. And here we should start from the splash screen, moving to sign-in screen, and do sign-in verification, do some sign-in. And as you can see with DSL, this code is pretty simple. And we should start from sign-in screen, because we speak about end-to-end test. A proper end-to-end test, from my perspective, is test which start from the very beginning. Because this test should emulate user behavior, and user always start from the very beginning. Opposite approach is use some mocking components. When we use some mocking components, let's imagine that we would like to mock our data layer. With our data layer, we can configure it properly. In DSL, you can have something like this, which can prepare all mocks which you needed for running this test. And here we have just two screens. Of course, this test will be much faster, because you don't need to spend additional time for traveling between different screens. And here we have some differences between these two approaches. First of all, it's entry point. In end-to-end test, we should start from the very beginning, and ideally we should do sign out when we finish, because next test should start from the very beginning. However, for optimization, you can use other approaches. Next, entry point in UI test, that we can start from any screen as we want. We can start just from a screen which we would like to test. Next situation with end-to-end test require interaction with server, because it's emulating user behavior, and we cannot configure in other way. End-to-end UI tests with different types of mocking have no interaction with real server. However, if you will verify mock responses from the server, it will be kind of interaction with server. And of course, this test much faster. I will write this three basic scenario. for end-to-end approach and UI test plus mocking. And UI test with mocking was faster for something like 40%. It was much faster than end-to-end approach. Next set of scenarios is search, because all applications use search, and it's pretty common scenario. First of all, when we open our search fragment, we download some data from the server and would like to display this data. Sometimes our server can have some problem, and ideally our client application should care about it and handle all this problem always problem good. And next situation, when we open our search fragment, download some nodes, enter some search request, press search, and we wait for the next data. And we will mostly discuss about the last scenario, because this scenario is most complicated. As you can see, with end-to-end approach, we also should start from the very beginning. And here we have a lot of interaction with server. First of all, during sign-in. Secondly, during downloading most popular nodes. And finally, we should think. And finally, when we search something, we should also care about it. And this test will be pretty long. Opposite approach is UI test with mocking, where we prepare some mock and start from required screen. And as you can see, this will be also much faster. Most tricky scenarios, especially for end-to-end test, it's handling error. If it's proper end-to-end test, it means that we cannot configure anything on this from our application, because we can test it if we redirect our call to another server or to another port. But we cannot it because our application haven't so option at the beginning. And this scenario will be almost really complicated with end-to-end approach. However, you can verify it without any problem when you will use some mocking. And here we have some additional differences. First of all, it's data from server in end-to-end test. If you would like to run your test in parallel, it will be a real problem. Because if we imagine two different scenarios running at the same time and working with the same dependency, like server or database, one test can read data and another test can update data at the same time. And we can have some problem, and our test data will be incorrect. Great benefit here is that we can test with UI test plus mocking view independently. Let's imagine that we have some screen with a lot of dependency and fragment with search. And if you would like to concentrate only on testing this fragment, you can create your test activity, add your fragment to this test activity, and just verify it. And UI test with mocking require a more or less good architecture. Because if you have poor architecture, it will be pretty complicated or even impossible to test it with poor architecture. And of course, this test much faster because we don't need to wait responses from the server. We can start from any screen as we want. We don't need start from splash screen. We can skip sign out because we can configure mock object properly for each test case. And the main question, should we use UI test with mocking for our scenario? Any ideas? Of course, no. And first of all, it will be pretty complicated to cover all scenarios with UI test. And main idea of UI test is that we verify how our UI reacts on changes in our data, in our model. And it will be complicated to cover all scenarios. In addition, in any of this case, you should have a lot of different tests like unit integration, because from my perspective, UI test with mocking it's UI unit test, where we verify UI. Solution for this problem is that we can introduce scope for regression testing. And this scope, it will be a set of end-to-end tests which will verify your application, how your application interact with real server, or it can be replica of your real server, it can be some debug server. And your application start from the very beginning, will verify all most popular cases. And you can be sure that your application work correctly with real server. But here, next question, how can we create or handle, update this scope? When you just start creating your application, you can start from some specifications. Because specification is a sort of truth connected with your application, and you can find most popular feature, business idea of your feature, and verify it via end-to-end test. Additional topic, when you have a lot of users, you can use analytical data. And you can find this 95% of all of your users use this feature. It means that you should introduce this feature into your regression scope. Coming back to efficiency, our UI test can look like this. First of all, we can have just few, or maybe 10, 20, depends on your application, end-to-end test, which will be pretty long, and a lot of UI tests. You can have situation when a big amount of UI tests will spend the same time as end-to-end test. Because end-to-end tests will be pretty long. However, during the same time, you can verify a lot of UI tests which have no dependencies. The next problem of all UI tests is flakiness. When I mean flaky test is that your test unstable. Let's imagine that you have one build and you run this build few times on continuous integration server. And one time it's fully green, sometimes it's greenish, mostly green, but you have some failed scope or failed test cases. And how can we work with it? First of all, we should think about reasons. I split all reasons into two different categories. First depends on our test and production code and tools which we use. When I mean tools, it's all frameworks, library, approaches which we use for writing this code, and of course it's emulator. Emulator is much stable in latest version on Android Studio, but it's not so stable as real device. And another big group is test cases and test execution process. First problem can be dependency. It's our web server, database. In case of web server, we can have problem with internet connections, and it can break all our tests. We can read some files from server, from our device. Next problem is test data. Your test data should be solid, because if on your server test data continuously will be changed, it will be really complicated properly with this approach. Next problem is long running test. You should understand that long running of test means higher risk, and you can have some additional problem with synchronization between different fragments, activity screen, and stuff like this. And of course, parallel execution. If your few test case work with the same database, you can have some problem because your data can continuously change on CIs on this database. If you try to fix all your problems and you have flakiness, you can introduce a handling flaky test on CI server. Let's imagine that we have results like this. It's mostly green, but we have some fail. First of all, we can collect all our fails and run it a few times. Let's imagine that we can run our flaky test 3 times, only red tests, because we should know this all red test or test suite, it's regression. It means that we break something, or it's because we have some flaky tests. And after a few runs, we can have this situation that half of this test once passed. It means that half of this is flaky test, And half of this, it's real regression. It means we break something. If we will think that all our failed tests, it's flakiness, it means that it will be really complicated to find real regression. Of course, if some test was green and right now red, yeah, maybe it's a problem. But if you have a lot of tests and you have some flakiness, it will be a real problem. If you introduce something like this to CI server, it will be much simpler identify if it's regression or it's just flaky test. And moving to last part of this talk, it's testing tips. Because really often developers write tests, and developers mostly concentrate on writing code and spend less time for writing tests. And first problem you can find in the very beginning. It's problem with names. Really often I see situation when test called just test or test 05 or something like this. And of course it's a real problem, because if you wrote this test, I don't know, a few months ago, and you come to this test, you don't know what means case 05. For you, for me, and especially for new joiners, it's absolutely nothing. And it's a real problem. Your test should have proper name, like verify sign in with incorrect data or with correct data. When you read this name, you understand what you should verify, and you understand this test scenario better. Next situation, connected mostly with new joiner. When new joiner joined to some big project, I think all old project have a lot of utils class, helpers class, extension class, and stuff like this. And if you spend some time for maybe not learning, but exploring these files, you can start do it much think better and faster, and you should learn different approaches which you have. First of all, you should think about project structure for avoid situation when you write a test and the same test exists on another file, because in project they use some specific structure of project, some specific package for only UI test with mocking, some for proper end-to-end test, and stuff like this. Next problem is when you verify too many cases, too many similar cases. Let's imagine that we have a search screen with search bar, and when user press to search bar and start write some request, we would like to cache it and promote it next time when user press search bar. It's really popular. It's a really popular scenario. But when I saw many tests connected with this topic, I saw that people try to cache 10 or 20 items, but it's not needed because all these items is positive cases, and we can verify just 1 or 2 items, and it will be much faster and it will work correctly. This problem, I think, connectly mostly means acceptance or end-to-end test, because acceptance test really long, and many companies has great idea. Okay, we should cover only positive cases. It's work sometimes, mostly awful. Let's imagine situation. We have 2 screens. It's our license screen and login screen. And of course, priority for the user for the screen is totally different, because maybe few percent, maybe not, will visit our license screen. And all user mostly use and start journey and meeting with application from login screen. It means on login screen you should verify all positive cases, positive and negative, because this screen is really important for your application and especially for all users. We'll be pretty sad if your user enter correct password and correct login and everything fine, but from some reasons he or she do some logout and enter some incorrect login name or password and have a crash. It will be awful experience for all of your users. It means that all your screen should have different priority, and you should think about all screen from priority perspective. And for some screen you should care only about positive cases. For some screen, you should care about positive and negative cases of your application. Each application has main business goal and business idea. For my application, main business goal is sharing great places on the map. And this functionality should work always perfectly. It means that you should always verify most popular cases from your application. The same situation with navigation. All your navigation between different screens should always work perfectly. Next problem, I think it's reason of it, it's our modern development. Because our modern development look in ways that we are looking for some library or framework, we are joining it to the project, and we start using it. And in some cases, we try to write some tests for external libraries. From my perspective, it's pretty strange idea. First of all, we can contribute some tests to this library if this library have no tests, because I saw a lot of tests when one of steps of verification UI is just scrolling recycler view. It's just scrolling and not verify anything, just scrolling. And it's just wasting time. It's totally wasting time, just do scroll and don't verify anything. I saw a lot of different tests for RX Java in project. And it's pretty strange because your project too big, probably too complicated, and you don't want to add complexity for verification external solutions. If you use your custom solution, let's imagine that you would like to replace recycler view with your custom solution. You can move it to external module, and in this module, write test only for verification, gestures, scrolling, swiping, and stuff like this. Just in one place, and it will be enough. This problem, I think, connected with poor architecture of application. Because if you have great architecture, you can combine different approach of testing, even UI. If you have poor architecture, your solution is use acceptance test or end-to-end test, if we speak about UI. And if you would like to achieve efficiency, we should combine different approaches. Because we can have few end-to-end tests and a lot of UI tests with different type of mocking, and it will be much faster. And you can cover most scenarios than if you will use only end-to-end approach at the same time. Try to work with Flaky tests. Stop collecting them. Because if today you have one Flaky test, in a week you will have 10. In a few months we will have hundreds. And try to find a reason. When you find this reason, try to fight with this reason or reasons. And if it's impossible and you have some Flaky test after all this fight, try to integrate proper handling of Flaky test to your CI server. And it will be much clearer for you when you take a look at your report and understand that, okay, this test Flaky and this test once passed, it means that everything more or less fine with our test. This problem connected with mostly developers who start from the development process. If you start from writing test, it's not a problem because your UI test will base on some specification. If you spend a lot of time for implementation, probably really often when you would like write some UI test, you skip coming back to your specification, read it again, and try to cover all cases from your specification. Your test based on implementation, and it's a real problem. Because implementation can have some problems, and specification is only one source of truth, how your application should behave and what your application should do. If you would like to avoid situation with fixing the same scenarios multiple times, convert all your bugs into test cases. It means that in few times someone would like to break something, they can verify most popular cases plus all bugs which you fixed previously. Many companies have QA department, and that's great. And my idea is that these people should concentrate on more tricky stuff on verification some applications before release. And if we automate many our scenarios, which can be verified without any person, we can save a lot of time for QI department, and they can concentrate on searching more tricky stuff, and your quality of your application will be much better. Oops. And last tip, that if you would like apply efficiency to your test, you should care about testability. If your application is testable, and you think about best practice, design pattern, interfaces, better approaches, you can apply this efficiency because you have much more possibilities. You can use simple acceptance test for some cases. For some cases, you can use UI test with mocking. You can use unit and integration test for verification different part of your application. So it was all from my side. I hope it was interesting. If you have any questions, I will be happy to answer for all of them. Thank you.
Hi, you were talking about dealing with Flaky tests. So like making some statistics and comparing and retrying and so on. Do you recommend some tools for something like that, or did you make the whole logic for that by yourself?
We have in our company, in our projects, we have a lot of our own tools, which we generated for controlling and collecting this data. However, you can find different even open source solution for collecting information about techniques, for running a test at the same time on different devices. You can find it without any problem. But in our case, we use some custom solutions.
Hi, thank you for the talk. My name is Artur, and the question is about flakiness. Again, sometimes it happens that that's, for example, a race condition or something like this, and a test is flaking not because the test is bad, but because your code is bad. Did you get some statistics, analytics about like how often do you have such cases?
Ideally, you should also have another type of test, like performance test, which can help you with finding some bottleneck places in your code. If you combine multiple different approaches, you can find it. You have a lot of static code analysis tools. You have a lot of linter. And this tool can help. This tool can help you. But as I talk, one of reason is tools which we use. It's one of reason of flakiness. And in our cases, we mostly handle them on CI, try to find reason and fix it, and it helps.
Hi Alex, thank you for an amazing talk. I have a question that is might be somehow out of the scope for the presentation, but still related to UI testing. I can see you have pretty much experience with UI testing on Android, and my question is actually because mobile developers also tend to struggle with platform parity issues like creating UI and UI testing. Do you know any of the solutions that we can apply for both Android and iOS UI testing from your experience?
It's frameworks with which you can test, if I remember correctly, web, desktop, and different mobile platforms. However, I had different opinions about it. If I remember correctly, from Android perspective, it's Appium under the hood use Espresso. It means that you have much layer of abstractions. And if you would like to extend something, it can be more complicated because you have more abstractions. And these abstractions will be more high level. And in some cases, it can be some problem. But I know that some big companies use Appium, and it works fine for them.
Yeah, and about creating tests based on specification, it's okay if you want to make end-to-end test. But in case if you are making, for example, Espresso test, when you often checking that, oh, okay, I called this method on my database mock, I called this method on some other thing, and so on. So can you somehow introduce the specification-based testing into smaller, like, as you said, unit-level UI tests?
Let's imagine, first of all, we can, if we would like to introduce something like this, first of all, we can create some interfaces, just interfaces, and mock these interfaces. And we can verify this with just testing this, interacting with this mock object based on interface. And later on, we can convert this test pretty simple to test which will verify some real data, partially for end-to-end test, and partially it can stay with. You can start from creating interface and some architecture of your components, and you can even, in this moment, you can start with writing this test. However, I think better solution if you stop development, coming back to the specification, read specification without thinking about code, how code was written, and you can read this specification and create your scenarios based on this specification, not based on some approaches which we use during implementation. Maybe some hacks, workaround, whatever. But main idea is come back to the specification, read this specification again, think about your test based on this specification, and just after it, write your test.
You talk about this flow when you first have splash screen, then sign in, yeah, etc. Let's say you also need to initialize something in the background. Yeah, you get some configs, things like that. And when you want to start test from some specific point, not from the start, yeah, how you want to handle this whole initialization process, yeah, to get user configs, yeah, things like that.
I understand your question. Let's imagine that, and it's a real sample from this app, that some screen require authorization. First of all, we can mock our authorization mechanism, and later on we can concentrate on some file. A lot of things depends on how you work with dependencies in your project. About dependency injection solution. If your architecture pretty good and testable, you can handle it without any problem, because this code which I showed at the very beginning, which I showed from the very beginning. Yeah, sorry. Yes, like this. Here we have. Okay. Here we have just a pretty nice DSL with one prepare method, which mock a lot of objects. Because real problem in tests that really often you have a lot of mock before some class, and this approach can somehow solve this problem. Of course, under the hood you will have a lot of code for this method, but it will be much simpler to understand, and you just keep concentrating on noise of your test. You just think about real implementation. If you have problem with initialization of all your dependency, first of all, think about architecture. Approach how can we change your dependency during or before running the test, and it should help a lot.
Thank you, Alex.